Hello everyone, I'm Dr. Ashish Bansal. I welcome you all to the third video of this series. In this video, I shall give you the solutions of question number 9 to 14 of ISC 12 Mathematics 2024 board paper. This is question number 9. It is a 4-mark question and it has an internal choice. The first part is evaluate integral x square cos x dx. We apply the integration by parts method. We take x square as the first function, cos x as the second function. Then to get this step, x square minus sin x minus twice the integral x sin x dx, we again apply integration by parts, taking x as the first function, sin x as the second function, and upon simplification we get the required integral. In the second part of question number 9, we are given an integral x plus 7 by x square plus 4x plus 7 dx. We have to find its value. So let I to be the given integral. Then we take the numerator and put it equal to a times the derivative of the denominator plus b. So x plus 7 is 2ax plus 4a plus b. Now if we compare both the sides in such a way that we compare the coefficients of x and the constant term, we get these two equations. These two equations can be solved to get the values of a and b as half and 5 respectively. We can substitute these values back in the first equation to get this expression. Now, using this expression, we can write the value of I as the sum of two integrals. If you look at the first integral, the numerator is the derivative of the denominator. So its value is log mod x square plus 4x plus 7. And this integral I take as I1. Now we compute the value of I1 to get the value of I. I1 is 1 upon x square plus 4x plus 7 dx. We now complete the square. We get this value and then apply the standard formula for this type of integral to get the required value of I. Question number 10. It is a 4-mark question. It says a jewelry seller has precious gems in white and red color, which he has put in 3 boxes. The distribution of these gems is shown in the table given below. This is the table which is given. Box first, second and third, number of white gems, red gems are given. He wants to give 2 gems to his mother. So he asks her to select one box at random and pick out any 2 gems one after the other without replacement from the selected box. The mother selects one white and red gem. Calculate the probability that the gems drawn are from box second. So we are given 3 boxes, first, second and third, with the gems mentioned in each of them. We define 4 events B1, B2, B3 and E as follows. B1 is box first is selected, B2 is box 2 is selected, B3 box 3 is selected, and E, one white and one red gems are drawn. Since selection of these 3 boxes is equally likely, so probability of B1 is 1 by 3, so is the probability of B2 and probability of B3. Now we can write this conditional probability E given B1. We have to pick one white and one red. So let us say first is white and second is red. So probability of one white is 1 by 3 and one red is 1 by 2. Because in the box first there are one white and two red gems. And these are the possibilities. We can have 2 cases here. First white, second red, and first red and second white. So in this way we multiply with this factorial term to get the value 1 by 3. Similarly, we can compute the probability E given B2 and E given B3. Now we can use the Bayes theorem to compute the required probability P B2 given E. And the answer is 18 by 43. Question number 11 is of 6 marks. It says the furniture factory uses 3 types of woods, namely teak wood, rosewood and satin wood, for manufacturing 3 types of furnitures, that are table, chair and cot. The wood requirements are given. It is found that 29 tons of teak wood, 13 tons of rosewood, and 16 tons of satin wood are available to make all three types of furniture. These are the three things that we have to answer. Firstly, we have to express the data given in the table above in the form of a set of simultaneous equations. Then we have to solve the set of the simultaneous equations by matrix method. And finally, you have to find the number of tables, chairs and coats so produced. So let us take that the number of chairs, number of tables, chairs and coats be x, y and z respectively. Then then this table helps us that to form the three equations. We have 2x plus 3y plus 4z equal to 29. 29 because there are 29 tons of teak wood available. Similarly, other two equations can be formed. This system of equations can be written in the matrix form Ax equal to B, where A is this matrix, X is the matrix, the column vector XYZ, and B is the column vector 29, 13 and 16. So this is the answer to the first part. In the second part, we have to solve this matrix equation. So we find determinant of A, which is 5. It is non-zero, so the given system of equations is consistent and independent. It has the unique solution given by x equal to A inverse B. Let us now compute the adjoint of A in order to determine the inverse. So that is a standard problem. One can easily compute the adjoint of A, and A inverse is 1 upon determinant A into adjoint A to achieve to this value. Now XYZ is X, which is A inverse B. Substituting values of A inverse and B here, we get this matrix 2, 3, 4. On comparing the two matrices, we get x equal to 2, y equal to 3, z equal to 4. Hence, we get the number of tables, chairs and coats as 2, 3 and 4 respectively. Now, moving to question number 12, first part. It is a 6 marks question. There is an internal choice. The first part says, Mrs. Roy designs a window in her son's study room so that the room gets maximum sunlight. She designs the window in the shape of a rectangle surmounted by an equilateral triangle. If the perimeter of the window is 12 meter, find the dimensions of the window that will admit maximum sunlight in the room. So we are given a window and we want the window to be having a largest area so that maximum sunlight enters. And let A be the area of the window, which has a rectangle of side of length x and breadth y, and there is an equilateral triangle surmounted on this rectangle. So side of the equilateral triangle is x. The perimeter of the window is given to be 12. So from this figure we can easily find the perimeter as 3x plus 2y. This gives us an expression of y in terms of x. So area of this triangle is of this window is area of rectangle plus area of triangle, which is xy plus root 3 by 4 x squared. We substitute this value of y over here and simplify to get this expression of A. Now we can compute the derivative of with respect to x to get this value. Putting dA by dx equal to 0, we get x equal to 12 by 6 minus root 3. Now second derivative of A with respect to x can be computed to get this value. Now second derivative of A at this value of x is negative. So by second derivative test is maximum when x is equal to 12 by 6 minus root 3. And for this value of x, the corresponding value of y is 18 minus 6 root 3 by 6 minus root 3. And these are the required length and breadth of the rectangle respectively. Now, moving to the question number 12, second part. We are given that Sumit has bought a closed cylindrical dustbin. The radius of the dustbin is r centimeter and height is h centimeter. It has a volume of 20 pi centimeter cube. There are four parts A, B, C, D. A part is express h in terms of r using the given volume. B part, prove that the total surface area of the dustbin is 2 pi r square plus 40 pi by r. And so then C part is Sumit wants to paint the dustbin. The cost of painting the base and top of the dustbin is rupees 2 per centimeter square, and cost of painting the curved side is rupees 25 per centimeter square. Find the total cost in terms of R for painting the outer surface of the dustbin including the base and the top. And D part is calculate the minimum cost for painting the dustbin. So let us now move one by one. Let us look at the dustbin first. It is in the shape of a closed cylindrical shape and the radius is R, height is H. Let us be the total surface area of this cylinder. Now volume of dustbin is given to be 20 pi. Using this information we can write pi r square h equal to 20 pi. So we get the value of h in terms of r. This is the first part. B part, in the B part we have to find the total surface area of bin to be equal to this expression. So the total surface area is the surface area of the top circle, the bottom circle, which is 2 pi r square, plus the curved surface area. Substituting the value of h in terms of r, we get the required expression. In the C part, we are given that there is a certain cost associated with painting the base and the top of the dustbin. So first we find, let C be the total cost of painting the dustbin. Area of the top and the bottom is 2 pi r square and the curved surface area is 2 pi r h, which reduces to 40 pi by r when we substitute the value of h. Now cost of painting the top and the base is given to be rupees 2 per centimeter square, whereas it is rupees 25 per centimeter square when we paint the curved surface area. So total cost is total of area of the top and the bottom multiplied by 2 plus total curved surface area multiplied by 25. So this is the total cost associated. Now we have to find the minimum cost. So we first compute the derivative of C with respect to R. We get this value. Put dC by dr equal to 0 to get R equal to 5. Then compute the second derivative of C with respect to R and its value at R equal to 5, which turns out to be positive. So by second derivative test, we can say that C is minimum when R equal to 5 and the corresponding value of C can be identified as 30 pi. Hence the required minimum cost is rupees 300 pi. 300 pi, the answer. Now question number 13, first part, it is a 6 marks question with an internal choice. It says solve the following differential equation and given that x equal to 0 and y equal to 1. So we first solve this differential equation. We are given this equation. This can be expressed in this form. Now we consider fxy as this function, the right hand side value, and f of lambda x, lambda y is actually equal to fxy. This means the given differential equation is homogeneous. So in order to solve this homogeneous differential equation, we put x equal to vy, that is dx by dy equal to v plus y dv by dy. Substituting these values and upon simplification we get this differential equation. We have the variable v on the left hand side and y on the right hand side. Now integrating both the sides and then substituting v as x by y again, we get this expression. Now given condition is x equal to 0 when y equal to 1. So we put x0 y1 in this first equation to get c as 2. We substitute the value of c again in first to get the required solution of the differential equation. Question number 13, second part, it's the second part of this question of the internal choice. It says solve that following differential equation this, and we are given that y equal to 0 at x equal to 2. So the given differential equation is this, which can be expressed in the variables can be separated and we can write dy equal to 1 by x square minus 1 dx. So if we integrate both the sides, we get this. Now this integral can be solved easily. We put this value as a by x plus b by x minus 1 plus d by x plus 1. Upon cross multiplying, we get this. Now comparing the coefficients on both the sides of x square, x and constant terms, we get these three equations. These can be simplified to get the values of a, b and d. A, b and d, these values can be substituted in the equation number 2 here to get the value of this expression, which can be in turn substituted in first to get the value of y. Now this is the given condition that y equal to 0 when x equal to 2. We put these values in third equation to get the value of c as log 2 minus half log 3 Now this value of c can be substituted again in third equation to get the required solution of the differential equation. Now question number 14, it's a 6-mark question. It says a primary teacher wants to teach the concept of large number to the students of class 2nd. To teach this concept, he conducts an activity in his class. He asks the children to select two numbers from a set of numbers given as 2, 3, 4, 5, one after the other without replacement. All the outcomes of this activity are tabulated in the form of ordered pairs given below. This is the table which is given. We have to first complete the table. Then we have to find the total number of ordered pairs having one larger number. Then we have to complete this distribution, probability distribution table. Fourth part is find the value of probability x less than 5. And last part is calculate the expected value of this probability distribution. So moving to the first part first, we have to complete this table. So 2, 3, 4, 5, these are the numbers which are given. So if I complete the table, so it would be like this, like 2, 2, 2, 3, 2, 4, 2, 5. So first this represents the first component of the ordered pair and this as the second component of the ordered pair. So in this way we can complete the table. The second part says find the total number of ordered pairs having one larger number. So out of these two, if you see, the entries on the diagonal have both the numbers as same and rest of the numbers have one larger numbers. So 3 in the first row, 3 in the second, 3 in the third, 3 in the fourth. So we have in all 12 ordered pairs which have one larger number. In the third part, we have to complete the probability distribution table. So we are given capital X as the random variable which denotes the larger of the two numbers. So X can attain the values 3, 4, 5. So probability X equal to 3 is 2 by 12. You can see from here 3 is bigger in this ordered pair, 2, 3 and 3, 2. And out of these 12, there are two favorable cases, so 2 by 12. For X equal to 4, if we count here 1, 2, 3 and 4. These are the 4 ordered pairs where 4 is greater. So 4 by 12. Similarly, for X equal to 5, we can find the probability as 6 by 12. So it can easily be completed. X is 3, 4, 5. So corresponding probabilities are 2 by 12, 4 by 12 and 6 by 12. So this is the probability distribution table. Now in order to find probability X less than 5, we need probability X equal to 3 plus probability X equal to 4. We add the two values to get half, and to find the expected value of X, we need to add the probability, sum the values of XPX. So we compute XPX and the sum is 13 by 3, hence the expected value of X is 13 by 3. That's all for this video. For rest of the solutions, you can see the next upcoming videos. Thank you so much.